So I was telling you how what the difference between. You able to hear me now?
Yes, sir. Yes.
Yeah, I was telling you how proper experimentally conducted research and just observational issues have a lot of impact on the outcome. This is one of the observations which you can see people observed during summer. A lot of people eat ice cream and also a lot of shooting observed in USA. A lot of people are killed and so many violence reported. So people, anybody can see that maybe people eat ice creams and maybe some issue like that. That's a simple observation study. But the fact is, if you guess, it's not about the link of those who ate ice cream and had involved in violent of crime kind of thing in any particular situation. But there's one factor which is out of way, it was hidden confounding factor, which is called hot weather. So you think now ice cream is and independently related to the violent crime, but people observation more ice cream sales and more crime. That's simple, anybody can correlate. But there's one important factor we miss, which is called hot weather. So sometimes you have such a problem when you plan work without any have proper experiment design. You may have simple observations. It is called observational study. People observe. People think many times if you do like this, you'll come up with like that. But there is a link will be there, but the link need to be established. Here, the link is hot weather. Okay. And this is called, it's not correlation, but it is called as a causation. People say, although we think that more ice cream sale equal to more violent, but here it is the other way, but it's there is a significant correlation, but it's not actually happening, but there's other factors involved. So that's why we are telling here, observer studies are prone to confounding variables that mask or distort the association between measured variables in the study. For example, here hot weather. And an experiment, you can see a random assignment, treatment individual to avoid confounding variables. When you do experiment, you have a lot of other variables, other confounding factors that can be really worked on. So that's why one can really avoid this kind of issues. So if you look at here, what are the goal of experiment design? Avoid experiment artifacts, a bias in a measurement of produced unintended consequences of experiment procedures. Conduct your experiment under natural conditions as possible, avoid artifacts. Many times you do research and some result will come, but it may not be the reason behind such a result, but maybe something else. You need to understand that that's called artifact. So keep in mind all those information when you plan a work. So there are other things part of experiment design. Eliminate bias. Use simultaneous control group. A control group is the group subject to left untreated treatment in interest, but otherwise experiencing same condition as treated subjects. For example, when a drug is given for 10 rats and injection, handling, and given drug, food, everything we are keeping, but how do you control handling effect? How do you control injection effect? How do you control light and dark cycle? All those things need to be exactly given to other set of animals so that the other animal also undergoes similar procedures but without drug. So this is called control. Most of the time we need to have control group. So without having control group, it is not really proper science, and it cannot be authenticated by your findings. For example, here many times placebo. You just people feel like patient treated with the placebos, including sugar pills, often report improvement. People think I have taken medicine. People feel comfortable and they get treated. They cure of particular illness. So, for example, 40% patient chronic back pain report improvement when treated with a placebo. So they think that I have taken medicine, but simple sugar pill sufficient. So this kind of effect will be there in many in present scenario. Corona, many people, there are so many treatments, so many things happening. Many times people think that this particular chemical drug is treating a particular virus, another thing. But it may happens by some other effect, not because of the drug. So we should be very careful. Even sham surgeries can positive effect. This is why you need a control group. Control group is maintained perfectly so that one can really avoid any bias. And randomization is another important procedure that need to be included in the experiment design. The random assignment of treatment units experiment study break the association between potential confounding variables and explanatory variables. There's other important factors. And blinding. Blinding is a concealment of information from a participant and researcher about subjects are receiving which treatment. For example, you have testing heart medication, two treatment, drug and placebo, single blind test where the patient don't know which group they are in, but doctors do, and double blind test where neither patient nor the doctors administering the drug which group the patients are in. So we need to maintain this blindness because since I'm taking medicine, I'm all right. People start thinking that itself started curing, but that should not be there. Most of the drugs now they're testing globally. The patient may not be knowing sometimes, even doctor may not be knowing the treatment. So when clinical trial comes, so these are all very kept in secretly and nobody knows. So that kind of rigorous test is required when you plan experiment design. Here, other thing, replication. So actually, you need to have individual unit to which treatment is assigned. For example, here experiment 1, 2, 3 are there. So we think that in experiment 1, there are 2 animals involved, whereas experiment 2, although the 2 tank we maintain these animals, but we think that there are here 4, there are another 4. So we think we count in 8 individuals and experiment 2 conduct. But in fact, it is a 2 tank, only 2 set of experiment. So this need to be avoided. Here, for example, experiment 3, where you have 3, 3, 8. There are 8 separately maintained separate tanks. So these separate tanks contribute to separate experiment in the part of individual. So when you do that, people say that a group is considered as an experiment, but you should be very careful about doing such a effect which is have a compound effect on that. So we should be very careful about it. Here, especially here, if you see this called the experimental design, especially 2 units, is a pseudo replication, because the same tank, the repeatedly 4 individuals are represented. Here also tank 2, you have the same 4 individual represents tank 2 only. So in fact, the 2 individuals represent the experiment 2, similar to experiment 1, but it's not. Although it's 8 individuals participated, but only 2 replicants. So that need to be, it's called a pseudo replication. Yeah. Here, that's what I want to tell you. So if, for example, if you have any issues on particular light is not working, water is not happening here, and the entire experiment tank here and here, both will actually have a compounding effect, which is not independently taken up. So you should be very careful when we do such experiment. So other part of experiment design is define a questions. What kind of questions you going to address? Hypothesis. Define the population interest. What kind of population? Where? What is the size of population? Are you planning to estimate particular Hyderabad? Are going to include Telangana? Are going to have entire India or Asia or global? So we need to have pre-planned what is the population size. And also you need to decide the sampling, how much you can sample. Is a 2% sufficient, 5% sufficient, 1% sufficient, depends on the population. So there are many, people, newspaper you come, there are people use, especially treating corona, the phase 1, phase 2 trials, some people use 100, 200, 300, 400. When it come to clinical trial 3, they use 30,000, 40,000, 50,000 kind of thing. So since it is it's going to be in a global treatment, people use hundreds of thousands of people which come from different ethnicity, different background, different like that. So the sampling is very, very, very important in any experiment. As we discussed previously, what is the replication, what is the bias, what is the design, how many repetition, all those things required. Similarly, when you plan actual numbers, you should always be very careful. What your target population? Accordingly, you can have sampling designs like that. And once you can have experimental unit, and you can have what kind of variables you're going to use, what kind of treatment structure, what kind of structure, all those information need to be planned before you start any research work. So at the end, you can say, write down the research problem and questions before data collection begins. A specific question that researcher plan examine must be clearly identified. This is a question I'm going to ask. The particular drug, if you take a 0.5 gram, whether it is going to be treated or not. And what are the other main goal? Design, explain partition of effect sources and variability, distinct components in order to examine specific question interest. Objective of a design experiment is to improve the precision of result and not to examine research hypothesis. So these are very important when you plan a specific question, and accordingly you design a population, design a sampling, one can really do it. When you define a population, it may be, as I mentioned previously, population is a collective of whole people or animals or plants, other items that researcher collect data from. Before collecting any data, it is important that researcher clearly define the population, including description of members, what kind of members you use, and entire population for which they want to draw conclusion will be focused on experiment. So you have defined a population, how much you required, what is that criteria you are looking for, like that. As I mentioned, the sample need to be properly designed, how much sample is required, and what is that sample, whether you can, the result of the sample or then draw from inference of the population, whether that sample you collect is representative of the population, need to be also very clearly spelled out before you do that. With this background, I just talked about how the design of experiment. I talked about properly you plan experiment, work plan, a question need to be answered, population need to be mentioned, and sampling need to be mentioned, bias, replication, duplication, and all the information need to be properly put as a framework, as a design experiment. Then we'll go to next topic where we talk about how to collect data. How do you collect data? Sampling techniques. So once you have the plan is ready, the next step is a collection of data and samplings. So here, before collect samples, we need to also understand, many of you know what is the variables, values, and I don't want to go detailed. And we need to have all information, how many variables are going to collect a particular population or sampling will do it. So this need to be keep in mind when you plan of this one. And in data collection, it can be as I mentioned, research studies and use data in many different ways. Data can be used to describe situations, sometimes explanation by something else. Data also can be collected in a variety of ways, but if sample data is not collected in appropriate way, data may be so completely useless and no amount of statistical torturing can salvage the problem. So unless, as previously mentioned, the data not to be properly collected, and you end up with all kind of problems, that is not possible. Okay, especially when you have a large number of experiment, and especially in like do research in science, and somebody want to repeat, somebody want to test your hypothesis, test your findings, this need to be properly taken. Sample population avoid bias. As I mentioned previously, individuals in sample population must be fair representation, entire population. Therefore, sample member must be randomly selected, avoid bias. If you are looking for strength of student, picking of student from football team would not be a random. So the randomness need to be maintained. There is no bias. You should avoid bias while doing it. For example, another how you normally end up with bias here is other case. You, in a cage, 1,000 rats, you have pick up first 20 you can catch for experiment. And similarly, a public opinion poll is conducted using telephone directory. Recently, some TV channel, they conducted telephone directory about a particular personality's popularity and all. So it's all done by telephone and all. So how many people have phone? How many people accessible by phone? You are actually biased towards using phone, and it's not true representative of the population. So that need to be careful. And you are conducting study new diabetics drug, and you are advertising participant newspaper and TV. Here also you are biased towards those who are reading newspaper, those who are watching TV. You select as a participant. That's not correct. So you should be very careful about choosing your samples and population. That's very important. And what type of sampling you can do it? There are many ways one can really do the sampling. There are here haphazard way of collecting samples, quota sampling, probability sampling, and I'll go by one how it is sampling is done. So we should be very careful about doing sampling. Basic method sampling selected, especially random sampling. If you look at selected by using chance or random numbers, each is individually subject to human, otherwise has equal chance of being selected. Drawing names at random numbers. So many times people use random numbers, choose a random number and pick up actually individual population so that it's not biased towards a person. Here, other set of sampling called systematic sampling. Every third person is selected for treatment, selected for a particular assessment of value kind of thing. So sampling is not conveniently you can't select. Here, other basic method of sampling also have somebody convenient sampling. People conveniently at a particular place, who are from that particular place. Hey, do you believe death penalty, like that? Some certain ID condition, then you can ask questionnaire people, and it is like it's not right way of doing it. So you should be very careful about using sampling, especially in a particular way. And there are other method called certified sampling, where divide a population into at least two groups and common characteristic, then draw some subjects, a group here. You can see here male, female, every alternative person is chosen for a particular experiment or conducted controlled group, like that. So you should be very careful about choosing actually the method which you collect data from the population. And there are other methods called basic sampling, cluster sampling. For example, when recently zero surveillance of COVID was done, that people randomly picked up some cantonment or a particular ward so that it represents Hyderabad or Pune or Delhi or Chennai, like kind of thing. So this is called cluster sampling. You just have a block and choose every person there and zero surveillance they recently did. So these are all kind of scientific proof. When they say in Delhi, 19 to 21% of people have antibodies against COVID-19, that means they have properly planned, sampled this kind of method where it represents true representation of Delhi, true representation of Pune, true representation of Chennai, kind of thing. So that's called scientific way of sampling. When you sample, it represents all the structure, all the locality, all the area, and all the people which come from Hyderabad. Similarly, that is very important. So when you have such data, you can prove beyond doubt that this is something like 21%, 23%, 40% people have such antibodies against this COVID-19. So this gives an idea how a sampling. So this chapter I just mentioned to you how sampling very important. There are many ways one can do it based on your work, based on population, based on geography, based on locations, and based on what question you're asking. So you can plan, but should be random. Some of them can be random, some may be kindly fixed, some of them can be representative of population, something, but it should be a scientific way of selecting population. So these are all things one can keep in mind while planning a sampling. So when you are sampling, what you do, the data collection. So as I mentioned previously, this is very important part of your scientific research is a data, actual data you are collecting. So when you have data collection, you have all kind of data you may have. You may have actual number. For example, you have continuous sample measurements, discrete, ordinal, nominal. You all end up with all kind of data. For example, height of person or weight of person, like that. And here you have number 3, 2, 4, 5 numbers. You have here ranking. There is somebody who's good at a particular thing, somebody vegetarian, non-vegetarian, and there's a giving a rank a particular person, and that kind of thing. There's no meaningful numbers. It's simple as two different species. So you have all kind of data when you're planning a large experiment. So you don't feel I can't count this kind of thing. It can be entered, it can be taken while doing either large experiment or scientific designs, scientific experiment. As I mentioned, you can have this kind of interval data. You can have ordinal data where you can have data excellent, poor, fair, good, all kind of information can be ranked and it can be taken 1, 2, 3, 4, 5 numbers. And many of you have done such a work, even nominal data kind of married, single, married, divorced, widowed, all kind of information can be collected in a numerical way so that one can really plan while doing analysis as well as doing a large data analysis for any interpretation of your research. So we should not just ignore that how we enter this data about single. This can be converted numerical and one can really use this information while analyzing data later on. So I don't want to go detail because you all, many of you would have basically done some basic data collection. People have idea of how data can be collected, but I just refer to you how one can really categorize this data into different categories like nominal, binary, ordinal, scale. So you have a nominal, you have continuous. This one, the favorite subject here. Here, gender can be used, male, female, kind of data can be even collected, and also you can have a data kind of thing ordinal where agree, strongly disagree, not sure, agree, strongly disagree. This kind of data also been collected as ordinal value, and also as a scale, as a numerical, one can really collect the continuous variables. So this data can be any range, not necessarily be a number. It can be a actual kind of sex, gender, all kind of information can also be collected that can be converted into in a number. So this way one can really collect the data. And so far I talked about experimental design. Then I talk about what are the issues involved in experimental design, bias and automation. Then I talk about samples. What are the samples? And I was talking about what are the data now. So you have now data, and you have what we do next. So when you have data, we need to look at what kind of inference of the data. What is the outcome one can really take out from the what data you collected. So basically, there is a branch. Many of you would have already be teaching the statistics, or many of you done a lot of statistics. But I just wanted to give you an idea about how those things is done. Actually, statistics is a branch of mathematics, many of you know, and it's whether what you collect, whether it's meaningful, how data is significant. That makes you the findings so that anybody can interpret that you are finding to similar situation others. And also, statistical applications are based on probability statement. It's not no statistics say that 100% are accuracy. Always we have some error, possible error. So always any inference end up with this particular treatment of a drug is effective 99.99% or 95% or 85%. So it always you say there's an error always there, and we say the probability. So if you treat 100 people, 85% people may cure based on our research and findings like that. So never a single statement you can say this particular drug going to treat particular disease. So nobody says straightforward. Everywhere there is a probability. It may be 99.99, still 0.1001% is left. So it's always a percentage as a probability of event occurring based on our sampling, because he never counted 100 people, 100 like that. So it's also the population level. So nothing is proved with statistics. That's very important. People say, if we do statistics, we can say, I have done statistics, I can prove a statistics. Statistics are reported. Basically, we say the probability occurring such event. We are saying reporting of event. And statistics report the probability that similar result would occur if repeated experiment. So somebody does an experiment here in India, Telangana, Hyderabad. If you publish a report, anybody elsewhere in the globe can repeat the same experiment, should obtain same result. That's the statistics says. So it can be repeated based on the experiment. So When you plan, it can be repeated. That's what SAT6 says. When you have SAT6, you have what you do, the data, facts, especially numerical facts collected together in inference, and use statistics, it converted in information. So normally the layman, the information goes like this, but the data collection, a lot of statistics involved here, and the layman knowledge, whatever collected, simply they say the people spend, especially during pre-poll election, spend millions of rupees money to do statistical survey for a particular person's familiarity or the likelihood to be elected in an election kind of thing. So they spend a lot of time, money, look for different set of people, economically rich, poor, men, female, young, all kind of information to collect. At the end, what we get, a particular X person has 35% popularity, but Y person have 55% popularity among the people. That's the only information we get. But the background we have, lot of data is collected, planned well ahead of 3 months, 4 months, and lot of statistics done, property estimated, and extrapolating population, whether they 40,000 sampling, whether represent enter India, or 50,000 sample represent enter Telangana, that need to be done by statistics. So that at the end, you have information where it can give you a particular fact. Actually, statistics is a tool for creating new understanding from set of numbers. So number to information. Basically, statistics gives an idea of information translated from data. And when you choose a statistical test, before you, when you choose statistical test, when you conduct biostatistician, when you do it, before we, as I mentioned previously, before you start an experiment, before you plan any, and before any study or plan, before you collect data, all information need to be clearly had a discussion with the biostatistician or experiment designer or something like that. You need to have, as I mentioned previously, all the information should have previously. Then only you can go. After collecting data, you go, I have collected like this, I want to do statistics, I want to test whether the significance of these two variables. It may not be appropriate and it may not be very helpful. So as mentioned previously, repeatedly also, when you plan experiment design, you have all the information, including maybe consultation. If you are unaware of biostatistician, you can have consultation. This way I'm planning, this many set I'm going to have, and this many number of population I'm going to get. All the information should be clearly collected and put in part of your experiment design so that you don't really worry about later on. So you should be very careful when before collecting data, not after collecting data. Why land statistics? As I mentioned, it's a properly conduct your own research and evaluate others' research. Many statistical design flaws, errors are still found in medical literature. These are all very common. You can find people do very flawed design of research and end up with this one. A simple experiment I'll tell you here. This is a paper published New England Journal, actually New England Journal Medicine, one of the top journal, not the toppest journal in the world, you can say. Anything published here used for immediately making medicine or any drug like that. Such a very top channels. So even any channel, any publication here, that means your data is perfectly all right. That can be used for any clinical trial that level. So people spend 15 years of almost 735 million rupees to study this study, NIH study. 161,000 women ages 50 to 79. It's one of the largest program such women health ever undertaken on calcium plus vitamin supplementation risk of fractures. That's something they did and published in paper in saying that it does not have any risk. It did not reduce fracture risk. That's what their question. Even vitamin D is not sufficient to have this published in New England Journal 2006. Okay, such a journal, such a money, such a NIH funded project, big scientists, doctors involved. But the serious flaw in the paper is very, very, you feel very bad about this one. There are few observations here. Inadequate design left many questions unanswered. Significant limitation study, including the low dose of vitamin D. Vitamin D is given very, very low dose. Allowance of calcium, vitamin D supplements. no, they also gave medication, supplement medication they gave. So they gave extra medication they gave. The women enrolled were not risk fracture. They have taken 50 years. It's not the right way of doing it. Low rates could be due to number of factors. High BMD, BMI of participant because this is not incorporated. Inclusion of little few women with 70 years old because this fracture happens after 70, 75, 80 years. The less number of women used in 70 years. Many participants are already using calcium, vitamin supplements, were on HRDC, hormone therapy. Oh, there are many flaws in the paper, but they could publish paper New England Journal Medicine. So you think there are 5, 6 flaws. The US about less number of people 70. Actually, they're supposed to be a more number of people after 75 years because they're the prone to fracture because of old age. And there are people are taking calcium vitamin supplement. They have not taken. So many flaws in the paper. So when you have such publication, what happens? So you should be very, very careful when you do analysis and plan work. People, big people do mistakes, especially if not planned well and it's not discussed with other people, not taken all the confounding factors. That's a very important part of that publication. And still it is there online. You can go and verify it is there. It's online. And so the role of statistics in research, as I mentioned, how important it is statistics required will validity, especially the study help answer the research question. Analysis, what analysis, how should this be interpreted, reported, efficiency, validity, analysis, efficiency. If the experiment is really correct or for use resource, all the information one can really use using statistics. A kind of statistics, there are tools. I will not go in detail, but I just give you an idea of how statistics are classified majority, descriptive statistics and inferential statistics. Descriptive statistics, you know very well how the graphical, numerical data showing graphs, summarizing information and a particular location, all the information which is given basically descriptive statistics where you have data like a minimum, maximum, mean, standard deviation, time, this kind of information given. It does not much involve complicated statistics. Simple, this much height, this much variation, this much deviation we found. What are this kind of information called descriptive, very basic information statistics. Other inferential statistics where you can make, there are many relationships between one or two variable, different variable, independent variables, and a complex thing one can use model. For example, drug which you want to test their implication of curing on a disease, you need to have all kind of information where age, sex, BMI, height, weight, sex, food habits, all the information. Combination of all the data one can really use, and that need to be analyzed together. At the end, a single statement can be made whether the drug has effective or not, irrespective of what the background which we collected. That's the way one can statistics can come up with at the end. So you have such a very complex statistics where you can use under this inferential statistics. Many times people misuse of statistics. I have seen many people. This has been misused. Before we go to misuse, I'll talk about use of statistics. As I mentioned, simply describe data, compare two or more data set, determine the relationship between existing two variables, simple relationship, test hypothesis, what maybe this one or that one, make estimate about population characteristics. For example, whether the population or a growing population, declining population, how the population get treated, all kind of information can be can be interpreted using the statistics. And predictive past and future behavior data also. One can really model, for example, many of you know the climate, weather, rainfall, all used models. People use hundreds of years data to model the prediction of weather, rainfall, and particular location or particular area like that. So this data also can be used to predict future behavior of anything, including climate. Google and other people use Facebook and all use AI, artificial intelligence to your behavior, what likely to buy, what your interest, what you're looking for in Google. So accordingly, they will predict our preferences and show us. In fact, in Facebook and even other public platform, there's a well-established procedure where they are doing like that based on our behavior, past behavior, and Google other things. They will show us what you likely to see in our web page. So this kind of information they use, statistics use, model our preferences and show that this is the one can really use. And use of statistics can be impressive to employees. That's always there all the time. And almost all fields human endeavor benefit from application of statistics method. However, the misuse of statistics are just abundant, if not more so. There are three type of lies, damn lies, and statistics. Benjamin yesterday. The figures don't lie, but liars the figures. Statistics can be used to support anything, especially statisticians. So this kind of information also available. So people distort your information, and especially some TV channel, when you have a pre-poll information, accordingly they just change the behavior of the data. Accordingly, they predict a particular candidate whether he can win or not. So that kind of thing always there to avoid, remove particular data set, remove particular artifact, remove particular outlier, so that they can change the outcome of the data. So that should be very careful when we involve in statistical analysis. There are two main sources of misuse of statistics. One is evil intent and part of dishonest researcher, and unintentional errors, stupidity, part of researcher who does not know any better. Maybe many of time we may end up here where we don't know what kind of statistics we do, whether you non-parametric, parametric statistics, when you have a lot of variation data we collect, whether we can do student t-test or we should manually u-test, all kind of things. People really do mistake unintentionally, especially researcher, which they have no much information on statistics, they have unintentional error, they do it. So this need to be avoided when you do like that. And when you do, you also have misuse of statistics by sample size, voluntary. You change, as I mentioned previously, you purposely collect information selectively so that I'll get such information so that favor a particular idea or hypothesis which I proposed, like that. And also too small samples. I purposely reduce a small size so that I'll get what I wanted to show others. That was possible. So and the last one, convenience. People use like that. So conveniently you change data accordingly. It's not original representation of data. People can do like that. There are other things like it's not. If you look at two graphs here, I think you don't find. If you look at the two graphs, both are same values. Here also 30,000 US dollar. Here also 30,000. But to show the scale has been changed here. If you look at here scale, to show that there's a significant difference here, people can change the scale here, the diagram B, and they can show that there's a significant difference. These are like evil intent, basically to show that although there's no difference, if you look at here, not much difference, but purposely distort your axis, show the difference. People do like that, misuse of statistics, so that, oh, there's a lot of difference between two of this state kind of thing. That is possible. And the other possibility is like here, look at here, these are almost same. Two values are same, 20, here also 20, here 5.4, here 5.4, but they make bigger size in graphics so that people think that bigger, large number like that, so that small number. It's supposed to be a 1/4 here, but it's not 1/4, it's a 1/20th kind of thing. So the purposely they distort the original data, misuse the presentation to the public so that this to show, magnify the result kind of thing. So we should be very careful about scaling the data, especially I'm telling about scaling. If your scale should be identical, it should not be anything different, or conveniently to show your result is better kind of thing. So, and also people use, while taking survey, there are a lot of questions, unintentional wording to elicit desired response. So purpose they don't ask a particular person what to think about particular person's popularity, whether he is doing really good for society or not. Such a question will not be there, but they'll ask other questions related to him, how his personality related to foreign ministers, how personality related to his speaking, all information unintentionally they'll put where so that the direct question will not be asked, so that avoid such a thing. So people, the survey question itself biased, so that you end up with your favorable answer, your favorable result. So people do like that. And the order of the questions, sometimes when you ask questions, important questions, they keep last. So get by the time people answer one by one question, they may feel tired and they may not be interested to answer question. So you need to have all the information in a proper way, a random way. One can really, if you want really scientific way of doing any survey methods. As I mentioned, self-interest. People are, somebody would have sponsored, they want to have such a thing so that they can really change that outcome of the result. So you should be very careful about that. And further, there are other issues like you have missing data. Sometimes you may not able to collect particular data, but still want to comparison. You can want to compare. You do it purposely. You do it because there is a 5 application, whereas other places you have 25, 28, 29. A large number of replication will be there. So you should be very careful about when you do data. Should be very careful about. And when you do also, you should mention missing data. Sometimes you don't have data, you are not collecting particular data. You need to be mentioned that data particular month is not available for collection, kind of thing. Should be very careful about. And precise number, people believe in this implies accuracy. So they need to be a very number. Sometimes we mentioned you collected 25, 30, 40 individuals and convert in percentage. What happened when you percentage, people believe that the sample size is only 100 or 80 or 40, but when convert in percentage, it will be a huge, they represent the particular population. You should be very careful about when converting this one. So you should give an actual number behind. Although it is 24%, but I collected only 14,000 people kind of. For example, recently, Delhi corona surveillance, they only surveyed 29,000 people in Delhi. But Delhi population more than 1 crore, and so is 29 is they think it's still sufficient sampling. So that's why one can really think of. So, but when you read only 29,000 people only they counted instead of 1 crore population. So we should be very careful about when interpreting the sample value to the whole population. You should be very careful about that. And you may have at the end. There are when you all but there are you do some statistics error. It's called statistical error, type 1 error, rejecting a hypothesis, null hypothesis when it's actually true, and concluding difference when one does not actually exist. And the other one is accepting type 2 error is called accepting null hypothesis actually false. This to be very careful while writing any final inference or anything like this. Should be very careful. But even you can also, there are many publications nowadays accept you need not have a statistical significance, but you can really mention that although it is observation different, but they are not statistically significant. Still, you can support your hypothesis, saying that lack of number of sampling that might lead to the less significance value. So all kind of error one can really avoid by properly putting this information, so that one can really understand what is reality in the field. So you should be very careful about while doing the error. At the end, I think I have come to the last slide, and we were asking how experiment design, what are things involved here, how do you plan, how replication, what are the method, what are the questions, and what information need to be collected, how many samples, size, what the population, how many, where, what kind of sampling required when you collect data, what kind of sampling procedure you follow. When you have done, then you have analysis. So all the information collected, then you go for analysis statistics. Well, you do analysis, you need to find out whether the data come from normally distributed, non-normally distributed. Based on that, you can use statistics, and based on statistics and without any biased, one can really infer a conclusion, and to the public conclusion is to whom one can really do it. So the experiment design includes everything from design to sampling to data collection to analysis to when writing your statement that the drug 5.5 gram milligram drug can really effective controlling particular disease from this particular population. Like that's a conclusion you can make. So for that you need to have all the information in hand and properly planned so that this can be repeated by elsewhere, so that this can be used to other people. So basically I end up here saying there are other type of statistics one can really do. One can really do start statistics, measurement ranking, frequencies, expected value, all the information one can really use in the statistics. Variety of way one can really use a variety of statistics available based on your data, based on your sampling procedure. One can use any of these statistical tests to interpret, infer your data collections. I think I stop here. Any questions? I'm sorry, I'm not able to really present properly, but whatever means I could do it. There is some problem with I don't know, internet connection or presentation.
Thank you very much, sir. Participants, we have a couple of minutes for a couple of questions. If you have any questions that you want to ask directly, Dr. Umapathy, you can ask. I'm just checking the chat box too, sir.
Yeah,
please.
yeah.
They are asking about we have recorded the meeting, so we will share the meeting recording with you later of the program is done.
Yeah.
Any question directly to this Dr. Umapathy for knowing about experimental design, research design, the process itself?
Sir, one question. Sir,
yeah, please.
Sir, when null hypothesis is rejected, does it mean there is a positive relationship between the dependent and independent variable?
Yeah, go ahead.
And it means only there is something relationship is there between the variable and independent variable, because we have to go for the check the p value and f critical value also. But lonely the null hypothesis cannot determine the relationship between the variable and independent variable and dependent variable, I think. So give clarity about it, sir, please.
Yeah, absolutely. I was telling you, statistics is a tool to twist actually what exactly you want. Keep in mind all the biologically significant need not be statistically significant also. All statistically significant may not be biologically significant. So you need to have a call whether such a relationship is really exist because of data wrongly collected, or because of data wrongly collected you are rejecting hypothesis. But in reality it is not correct. It is something else. So that's the biological relevance. So always interpret your data collection with biological inferences. So when you have null hypothesis rejected, but although it is wrong, but you can say that due to sampling procedure or something random effect, some might have happened. That's the reason I'm rejecting. But still, you can go after biological relevance.
Okay, so thank you. Sir, what is the use of t-test?
T-test is just to make two different variables. For example, two population you have, one population given treatment, a particular drug, other population not given treatment. So these people of 100 people, 80 people are queued with various parameter, blood parameter we are checking here. Another 100 people here. So whether the drug is given, this fellow whether really effective with reference to the people other side where we are not given any drug. When you compare two set of variables, you do statistics test, these statistics, student T test basically. So then there's a difference. Then you say that the drug has impact on the population. So to test two variables basically, provided you have your data collected, it forms normal distribution. If the population not comes from normal skewed distribution, you need to use some of the statistics. But simple difference between two variables, you use these statistics. Yeah.
Are there any more questions, please? Okay, I don't see that, any more questions are coming up.
Sir, I have a question, sir.
Yeah,
Excuse me,
please,
sir.
please. Yeah, please go ahead, madam.
Sir, you have just explained about the sampling techniques, sir. Sampling techniques.
Yeah.
So can you please tell, sir, which type of sampling techniques are used in chemical science field, sir?
Actually, for example, yeah, tell me, go ahead.
So I'm a little confused. So which
Specific.
example I want?
Specific. You ask me specific procedure test. Anything you want to know?
Suppose. Yeah, sir. Specifically, I want to know. Suppose we are synthesizing any drug, or in relation to with this synthesis.
Mm-hmm.
Can we use any sampling techniques?
Yeah. See, sampling is to test. So, for example, you have a drug which you want to test whether it is effective in that model. Basically, if you want to test a particular drug, so you go to animal house. So you need to choose a population. So, for example, a male or female, what age, young age, adult, young adult, and older adult. So you have this when you want to test where the drug, you can't just choose whatever rats which are very breeding, very ideal conditions. So you need to choose their random sampling. There, some of them you have to take young ones, some of them take adults, some of them take older adults. So that's called sampling. So that's why I'm saying representation of when you test a population in a model, you need to have representation.
Then we will know. Okay, sir.
Yeah.
Okay. So what I mean to say that, sir, after our completion of work or after synthesizing that particular drug only, we can go for the sampling technique, right, sir?
Yeah.
Okay, sir.
Yeah.
Okay, sir. Okay. Thank you, sir.
Are there any more questions, please? If there are no more questions, I would request one of the participants to propose the vote of thanks to Dr. Govind Swami Umapathy. Is Dr. Ragasudha there? Dr. Ragasudha? Or one of you who have just asked the question, you can do the honors, please.
Sir, can I propose the vote of thanks, sir?
Please go ahead, madam.
Okay, sir. Thank you. Very good afternoon to one and all. It's my privilege to propose the vote of thanks on behalf of UGC-HRDC and all the faculty members of government degree colleges and on my personal behalf. So I express my sincere gratitude to Professor Dr. Umapathy, the senior scientist, who has spared his precious time and focused on various aspects related to research field, that is the various experimental design and the sampling techniques, data collection, and various statistical methods, and many more, sir. So I really thank you from the bottom of my heart. Thank you very much, sir. Thank you.
Thanks a lot, Dr. Umapathy. Thank you, Ms. Sarita, for that wonderful vote of thanks. Thanks a
Thank
lot,
you, sir.
Dr. Umapathy, for holistic kind of presentation that showed us what needs to be done with respect to research design or experimental design, and you have also kind of touched upon the statistical analysis, which I would like to just inform my participants that we would be paying attention from tomorrow evening onwards. We would be having sessions on understanding statistics. So we would be having Dr. Bhattacharyalu, who's the assistant professor, senior assistant professor at statistical department. He is going to give us theoretical information about the application of various statistical tools in research, and then that would be followed by a couple of sessions that I would be taking to tell you about how exactly we can do the analysis using free softwares that are available, which are not only on Microsoft Excel, but also we will be talking about some more wonderfully helpful softwares that we can use for doing statistical analysis, and how you can present your results, etc., etc. So those are the things that have been kept in the coming days. So we stop here with Dr. Umapathy, and I thank you very much personally, Dr. Umapathy, for you having accepted our request and sharing your experience with research design, etc. So we'll wait for the next resource person, Dr. Felix Bass, to join us. Dr. Felix is from the Department of Botany. He is from Central University of Punjab, and he is going to speak about cognitive biases in scientific research. So we'll wait for him. And yeah, Dr. Bast is already there. Dr. Felix is already there. So I can take up his presentation in few moments from now.
Thank you, Dr. Srinivas.
Yeah.
Bye.
Thanks a lot, sir. Yeah.